Question 10 is asking us to find an equation in any form for each of the following lines. And I've just split it up a little bit here, so I'm going to start with parts A, B, and C, and then continue with D, E, and F later. All right, so starting with part A. Part A is telling us the line goes through the points 1, 1 and 3, 20. And so to start out with, I'm going to find the slope of this line, which is m. And the slope is equal to the rise over the run between 2 points on the line, which is equal to y2 minus y1 over x2 minus x1. In this case, I'm going to call this first point x1, y1, and the second point x2, y2. So plugging that in gives me 20 minus 1 over 3 minus 1, which gives me 19 over 2. And that's as much as I can simplify that slope. So my slope is 19 over 2. And now we can just use our point slope equation for this line. And if we remember, that's the equation y minus b over x minus a equals m, where m is our slope and the point AB is a point on this line. So we can use either of the points we've been given here, but I'm going to use the point x equals 3, y equals 20. So plugging that in gives me y minus 20 over x minus 3 equals my slope m, which is 19 over 2. And then we can just rearrange this a little bit so it's nicer by multiplying our x minus 3 over to the other side, which gives me y minus 20 equals 19 over 2 times x minus 3. And so that's the equation for the line in part A. Moving on to part B. Part B gives us a point on the line, -1, 2, and tells us that the line is parallel to y equals 5x minus 7. So we know if lines are parallel, this means they have to have the same slope. So if we look at the equation of a line here, this has been given in the form y equals mx plus b. So m is our slope, so our slope from this line we get is 5. And that means the slope of the line that the equation we're looking for is also 5. So our m, we know, has to be equal to 5. Okay, and now we can just do the same thing using our point slope equation, which I'm going to rewrite here as y minus b over x minus a equals m. And I'm going to use the point we've been given, -1, 2. So my value b is 2, and I have y minus 2 on the top. And then I have x minus a -1 on the bottom equals m, our slope, which we know is 5. And we can again just rearrange this a little bit. This is going to be equal to x plus 1 on the bottom, and I'm going to multiply x plus 1 over to the other side of the equation. So I get y minus 2 equals 5 times x plus 1. And so that's the equation of the line in part B. For part C, I'm just going to rewrite it or write it over here. For part C, we have a line going through the midpoint of the line AB and perpendicular to AB with A and B given as the points there. So the first thing we can do is figure out what this midpoint is that ends up being a point on the line that we're interested in. And the equation for finding the midpoint of a line segment, mid equals between 2 points, you take the average of each of the x value and the y value. So that ends up being x2 plus x1 over 2 for the x value, and y2 plus y1 over 2 for the y value. And that's going to be equal, if we plug in, I'm going to say that A is x1 and y1, and B is x2 and y2. This gives me 11 plus -3. Sorry, that's really messy. Over 2. And for the y point, gives me 5 plus -7 over 2. And so 11 plus -3 is 8 over 2. And 5 plus -7 is -2 over 2. And just simplifying that down, 8 over 2 is 4. -2 over 2 is -1. So x equals 4, y equals -1 is the coordinates of my midpoint. So the next thing I want to do is figure out the slope of my line. We've been told it's perpendicular to the line AB. And so if points are perpendicular, if lines are perpendicular, the slope of one line, M1, is equal to the negative reciprocal of the slope of the other line, which I'm going to call M2. So let's figure out the slope of line segment AB, which I'm going to call M2. And that's going to be equal to y2 minus y1 over x2 minus x1, which I've assigned to points A and B as above. All right, so plugging that in gives me 5 minus a -7 over 11 minus -3, which equals 5 plus 7, which is 12, over 11 plus 3, which is 14, which equals 6 over 7. So the slope of the line we're interested in, M1, is going to be the negative reciprocal of this. So it's going to be -7 over 6 is the slope of the line we're interested in. And so finally, we can just plug what we found into our point slope equation. So, which is y minus b over x minus a equals m. And I'm going to use our point we found here for a and b. So this gives me y minus a -1 over x minus 4 equals our slope m, which is -7/6. And just rewriting that over here, sorry, this is getting a bit squished. This is going to end up being y plus 1. And if I multiply my x minus 4 over to the other side, I get -7/6 times x minus 4. And this is the equation of the line in part C. So part D is telling us that the line goes through the point x equals 15, y equals -2, and is parallel to the x-axis. So if a line is parallel to the x-axis, this means that its slope, or m, is equal to 0, because it's a horizontal line. And so we can plug this into our equation, our point slope equation, and this gives us, for a point slope equation, y minus b over x minus a equals m. We have y minus a -2 over x minus 15 equals 0. So this is going to be y plus 2 on the top. And if I multiply my x minus 15 over to the other side, this gives me y plus 2 equals 0 times x minus 15. And so that's going to just be 0 on the right side of the equation, which gives me, if I subtract 2 on both sides, y equals -2. So the slope of this line, since it's horizontal, is just y equals -2. For any value of x, y is going to be -2, and it's going to be a horizontal line. So moving on to part E. This line goes through the point 8, 0, and is perpendicular to 2x minus 3y equals 0. So the first thing to do is find out the slope of that line that we've been told it's perpendicular to. So rewriting that, it's 2x minus 3y equals 0. And I'm going to add 3y to both sides to rearrange this a bit. This gives me 2x equals 3y. Solving for y by dividing by 3 on both sides gives me y equals 2/3 x. And so this is in the form y equals mx plus b. So 2/3 is m, which is the slope of this line, and we know we want it to be, we want a line perpendicular to that, so that's going to be the negative reciprocal of the slope. So m, the slope of the line we're interested in, is a negative reciprocal of 2/3, so it's -3/2. Okay, and now we can plug in our points for the point slope equation, and this gives us y minus 0 over x minus 8 equals our slope m, which is -3/2. And rearranging this and multiplying x minus 8 for both sides of the equation gives us y equals -3/2 times x minus 8. So that's the equation of the line in part E. And part F, I'm just going to put over here. Part F tells us that the line goes through the point 2, 3 and is perpendicular to the x-axis. So for a line to be perpendicular to the x-axis, this means that it has to be parallel to the y-axis, which means it is a vertical line, so therefore its slope is undefined. So this vertical line is going through the point x equals 2, y equals 3, and since it's vertical, we know that it's always going to go through x equals 2. And for any y value, x is going to be equal to 2. So that means that the slope, the equation for this line is just x equals 2.